In this recording, we're going to review some of the prerequisite skills for our Unit 2, the rational numbers. So you should work through this on your own and then just play the recording when you want to get help or want to see the answers and see if you're right. In our first example, we have a simplify of polynomials. Basically, it's a polynomial minus a polynomial plus a polynomial. I treat this one as combined like terms. With a subtraction, I'm always going to change the subtraction into addition of opposites. So I'm going to negate both terms inside the parentheses. So I'm going to change this to a negative x cubed plus 5x. Now it's just a matter of let's combine any like terms. So here I've got a negative x cubed. Here I've got a negative 2x cubed. I'm going to call that negative 3x cubed. And then as far as x squareds, I only see the 1x squared. I'm looking for x's. I get minus 4x plus 5x plus 3x. That looks like a 4x. And then for numbers, I just see 7 minus 13 looks like minus 6. Okay? It's just a simple combine like terms in terms of the polynomials. Here I have to distribute. I have to multiply a binomial times a trinomial. And I'm going to end up with 6 terms because I'm multiplying 2 terms, and each one of those 2 gets multiplied by 3, so that's 6. So write out all the terms you have. We've got 6x cubed, all right, when I'm distributing the 3x to each of these terms. 6x cubed minus 15x squared plus 12x. Okay, now I'm going to turn it over and multiply the 2 by all the terms in the trinomial. So it looks like 4x squared minus 10x plus 8. Okay. Now it's just a simple matter of combine like terms. It's only one x cubed, so that's 6x cubed. Look for x squared, I get minus 11x squared plus 2x, and then just the 8. Okay. So again, to be able to multiply binomials is critical here. Okay. Now here to be able to factor with a GCF. So I'm looking for numbers that go into all the coefficients. I only see a 2. Okay. I'm looking for x's, so I need the smallest exponent of x's, and that's just an x to the 1. And same for the y's. I look for all the smallest exponents. So the only common amount of y's is just y to the 1. In parentheses, I'm going to write what's left when I divide each one of these terms by 2xy. Okay? So it would be, in the first case, 2x cubed y. In the second case, minus 9x squared. By this one, I would have plus 5x. And finally, minus 3y. Okay, I can check this by distributing everything back. I should get back to where I started. However, in this case, my GCF, well, I don't have any number that goes into all 3 terms coefficients, so I'm just going to look for the a's. And there is an amount of a's, and there is an amount of b's, so it's a b squared. And then just put in parentheses what's left when you divide each one of these terms by ab squared. Looks like negative 2a squared. Looks like plus 3ab minus a b to the second. Okay? Again, check it by distributing out. Here it says factor each one of these expressions completely. And it also, just for purposes, identify the type of factoring. So I look here, I see this is a trinomial. This is just a trinomial with a leading coefficient of 1. Okay, and I know what to do with that kind of trinomial. So I'm looking for numbers that multiply, it's supposed to be a parenthesis here, multiply to be 51 and add up to negative 20. Well, you might not know that much about 51. It's not a number we use that often, but turns out its factors would be 17 and 3, and they both need to be negative to have a positive product and a negative sum. Circle each one of these. Go back and circle up here. I guess it's obvious. I'm looking at this. Boy, it looks like a difference of 2 squares. The square root of a to the 8th is simply cut the exponent in half. So I'll have an a to the 4th minus b squared a to the fourth plus b squared. Okay. Now, I'm looking right here. Maybe this is a difference of two squares. Sure enough, the exponents are even, so they're both squares. So I'm going to split that up further. I have a squared minus b, a squared plus b. Right? That's just the factorization of this. And then finally, this can't do anything with a sum of two squares. So that just stays as it is. A to the fourth plus b squared. Okay. That's our final answer. So we use the difference of two squares factoring technique twice there. Right here, the first thing I'm always looking for is a GCF. I see a GCF of 5y. Pull that out. Okay, so I've got 5y in parentheses. What's left? It's going to be a y squared plus 3y minus 4. Now that can't always factor any quadratic, but in this case it looks to me like we can factor this as leading coefficient of 1. So I'm looking for numbers that add up to 3 and multiply to p, negative 4. Okay? So we've got a y here, y. I've got a 4 and a negative 1. And that's the final form here. Okay. Interest of time, I am just saying the factoring techniques. I hope you're writing down the type of factoring that's used. Okay. Next, I see another difference of two squares here. I see a square, even exponent. 4 is certainly a square. Square, even exponent. So let's factor that out. I've got the square root of z squared is just z. And the square root of 4y squared would be 2y. Z plus 2y. That's done. This one, well, I don't have a greatest common factor, but I looked for it. And so in this case, I'm going to multiply 6 times negative 5 to negative 30. And I need numbers that multiply to be negative 30 and add up to 7. So let's see. Could try 5 and 6, no. 15 and 2, no. Let's try 10 and 3. Yeah, 10 and negative 3, that'll do it. So I've got here a 10 and a negative 3. All right. So what we're going to do is split up the 7x as 10x minus 3x, which is equivalent, right? It's equivalent to 7x. So make a window, put those 4 terms in the window, and then I just need to factor out GCFs. So it's really going to be important in this unit that you're really handy at factoring. Okay, so I put the 6x squared top left, the constant negative 5 bottom left. The order of the other two terms does not matter. Get a different color here. GCFs on the outsides. So I've got 3x here, 5. Don't know if it's positive or negative yet. Hold off on that. Across here, 2x. Across here, I don't see much. Just a 1, I guess. I'm going to put a negative on the 1 because both of these are negative, and then it all works. So my factorization looks like, right up here, 3x plus 5, 2x minus 1. Okay, that's the factorization. Let's shoot over to this one. I do see a greatest common factor, so I'm going to take that out first. So greatest common factor is 3, therefore it's x squared minus 2x minus 8. Okay. Always look for your greatest common factor. The window will not work if you don't pull out your greatest common factor, and there is one. Now I need to see if I can factor this further. I think I can. I've got 3, I've got x minus 4, I've got x plus 2. And that's the factorization. Can't go any further with that. So greatest common factor, and then just factoring a trinomial with leading coefficient 1. Let's shoot over to this one. I see difference of two squares. But before I see difference of two squares, I should take out the GCF. So I've got a 4 in front, and I've got an s to the 4th. S is kind of a stinky variable. I don't know why we used that there, but it is what it is. S to the 4th minus 16. Okay, S kind of looks like a 5. I don't like it as a variable. 4 is still in front, but I have a difference of two squares here. So I've got the square root of s to the 4th, which is s squared, plus 4, and then s squared minus 4. Okay, there's a 4 here. Let's make that clear. And then here, this is a difference of 2 squares, so we're going to do difference of 2 squares one more time. So I've got 4 in front, s squared plus 4, and then I got to break this down, s plus 2 and s minus 2. That is the final factorization. So it was GCF, then it was difference of 2 squares twice. Okay? Factor by grouping. I'm going to need a little space to do this one, factor by grouping. Do that one over here. So I'm going to put each one of those terms in the panes of the window. First term top left, so that's a 3x cubed. Last term bottom right, that's a minus 4. The other two order doesn't really matter, so I'll go minus 12x squared, and I'll go with a positive x. Take your GCFs, put those on the edges. So, looks like right here, 3x squared. Coming up, just a 1. Not sure if it's negative or positive, I'll leave it. Going across, x. Going across, 4. Looks like the 4 should be negative because both its terms here are negative. That will work out. So my going back over here, now I can write the answer. It'll be a 3x squared plus 1. That's coming off this and this dimension here. And then it's x minus 4. Again, we check this by distributing it out. It should confirm the answer. Okay. Next, doing a little work with fractions, because this unit's about fractions. It's rational expressions. So it just says simplify. Simplify just means divide out by a common factor. I think 2 goes into both, so let me start with that. 47 over 6. 2 doesn't go into them anymore. 3 doesn't. Well, that's it. Simplify. 1350 seconds. Well, 13 goes into both. 4th. Now when we add fractions, we got to be comfortable just adding, subtracting, multiplying, dividing numerical fractions. We need a greatest common factor when we add. So here the greatest common factor to me looks like 35. So I'm going to rewrite this as 4 over 7, leave a little space, plus 3 over 5. Use another color here to illustrate. I'm going to multiply the top and bottom of this by 5 over 5, because that'll get me a 35. In this fraction, I'm going to multiply the top and bottom, the numerator and denominator, by 7 over 7. That'll get us a greatest common factor, excuse me, a lowest common denominator, let me say it correctly, of 35. So I've got a little 35. When I multiply the numerators here, it's 20. So 20 35ths plus 21 35ths. And now the easy part. Your denominator stays the same when you add fractions. You're basically combining like terms. Now you're adding up the numerators, but the denominators stay the same. It's just like when you add terms that have an x in it. You don't do anything with the x, you just keep the x. Okay? When we have subtraction, I encourage you to rewrite it as addition. Addition of opposites. So I'm going to make this 8 thirds plus, I'm going to make this a negative 13 fourths. I need a greatest common factor there. So let's go with something that's going to, 3 and 4 are both going to go into, let's make it 12. So I'm going to multiply this one by 4 over 4. Again, the form of 1 here, I can always multiply by 1 and not change the thing's value. So go ahead and multiply across. We've got 32 twelfths minus 39 twelfths. Works out to be negative 7 twelfths. Just combining the numerators. Again, I said I was going to make it plus negative 39. Just when you're dealing with subtraction, I'm going to recommend making addition of opposites. Multiplying. We can do this multiplication a lot simpler. Rather than multiplying across and getting 30 over 72 and then having to simplify, let's just simplify first. 15 and 8 don't share any factors, but I can change the order when I multiply, right? So really I could have put that 9 right under the 15. I'm going to divide 15 and 9 by the common factor of 3. So I've got a 3, I've got a 5. I'm going to divide the 8 and the 2 by the common factor of 2. So I've got a 1 over 4. It makes the multiplication a whole lot easier. Just multiply 5 times 1, 4 times 3. You've got your final answer. That can't be simplified. When we divide, what we do is rewrite the division as multiplication by the reciprocal of the second fraction, which is called the divisor. And now I've turned it into multiplication. And we know how to multiply. We just did that. We multiplied before by simplifying first if possible. 12 and 7 don't share a factor, but 12 and 20 do. Divide by, should divide by, I'm going to do that. I should divide it by 4. So I've got a 5 on the bottom and a 3 up top. 21 and 7 divide by 7. So I just multiply across. 3 times 3, 9. 1 times 5, 5. All right, finally, it's going to be important when you're adding fractions that you're comfortable finding a lowest common denominator. So out of all these denominators, don't look at the numerators at all. They're not involved. 2, 7x, and x. Well, first I'm just going to look at the numbers. The lowest common denominator of 2 and 7, because they don't share any factors, is just their product, 14. And lowest common denominator of x and x is just x, so it'd be 14x. It's the smallest multiple that they all can multiply by something to produce. Over in this example, well, 6 and 2 do share a common factor, so the lowest number that they both go into, their lowest common multiple, is 6. And then m and m squared, really the trick for the variables is just take the largest of the exponents, because m can go into m squared, but m squared can't go into m, if you understand what I'm saying there. Okay? Next bullet says, be able to identify a solution as extraneous. That's going to occur in this unit as well, just like it did back in our last unit with absolute value equations. Extraneous solutions are ones that don't check. Okay? They appear to check. You didn't make any mistakes, but they don't check. Okay? Finally, to solve fractional equations, we're going to multiply all terms by the greatest common factor. Multiply all terms by the greatest common factor. So our greatest common, fix that. I wrote the wrong word. Now I've got it. That's the greatest, it's the lowest common denominator of all the denominators. Okay, so you're going to look at the 3 and 5 and 15, and we want to multiply all those terms by the number that they all go into, the lowest number, which would be 15. Okay, so I'm going to change it to addition of opposites. I'm going to multiply all terms in the equation by 15, because I can do that in an equation. I can come through and multiply all of them by the same number and maintain the equality. It's like multiplying both sides by the same thing. The cool thing is, it divides out all your fractions. So 15 over 3, 15 over 5, and 15 over itself. Now I just have 5 times x, 3 times negative 2, so that's negative 6, equals 19. And that's an easy one to solve. Subtract or add 6 to both sides, divide by 5, and you've got x equals 5. That's how you solve a fractional equation. We're going to do the same thing with a proportion. I'm still going to multiply both sides by the LCD, which would be 4x. So I'm going to put a little 4x on both sides, a little 4x over here. And then when I do that, when I divide this side, the 4's divide out. Divide this side, the x's divide out. So I have a 4 distributed to the x plus 24. So 4x plus 96 equals 5x. And then when you subtract 4x from both sides, you get x equals 96. That's our answer. So it's critical that you can eliminate the fractions by multiplying all terms by the LCD of the denominators. Write that down. We're going to use that technique. Thanks for watching.